Hey, what's going on YouTube? Welcome to the next installment in our series building a render engine in C++. Today we're going to implement the long-anticipated model loading system. In this tutorial I'll cover how to export models from Blender for this project, the intricacies of Obj file loading, and how to convert that data to a usable format in graphics programming. That's enough of an introduction, let's just jump right into it. To begin with, I'm going to show you how to actually export a model. I've already created a model for testing here. To export it, go to File, scroll down to Export, and then select Wavefront OBJ. You can rename your file to whatever you want. For this project, I'll choose model.obj. And then right beneath the Transform tab, you select that, and you have to make sure that triangulate faces is selected, otherwise it won't be able to load the model with the way we're going to be loading them. Make sure that's selected, click export, and you're good to go. To set up your project for this tutorial, I need you to create a new folder called res in your project directory. In the description, I have provided 2 OBJ files. You're going to need to download those and drag them into the res directory, because we'll be loading from there during the tutorial. With that out of the way, I'll start by explaining the Obj file format. On the screen, you will see an example of an Obj file. This is one of the simplest file formats that are commonly used to store and load models. At the top of the screen, there are comments, a name, as well as a material specification. For the purposes of our loader, we will completely ignore each of those lines. What we care about are the lines that start with a V. If a line starts with a V, it means the next 3 floats are position data. These positions are vertices, vertex locations relative to a central axis, which is 0, 0, 0 for XYZ. Now if a line starts with VT, it means that the next 2 floats are texture coordinates, or UVs. These UVs are essentially 2-dimensional coordinates on an image that will be used for interpolating between images, pixels, during the render process. Now we're going to cover that later. I won't go into any more detail right now, but when we do the tutorial on texturing, that's the first thing I'll cover. Finally, if a line starts with VN, it means that the next 3 floats are vertex normal data. Again, I'm not going to go into too much detail now, but these are lines that essentially indicate the direction that a vertex is pointing, and we're going to use that for lighting. Now, with all that out of the way, there's one final piece of data. This is arguably the most important. And this is the face data. When you're rendering an OBJ file, you essentially take 3 indices and then you draw a triangle at each of or between those indices. Those indices point to a vertex which contains a position, a texture chord, and a normal. And the way the OBJ file actually stores this is it has an F at the start of it, and then it points to a set of 3 numbers. And those numbers are separated by slashes. The first number is represented as a vertex, the next one is a texture chord, and then the third one is a normal. And those are all indices in the order which the file gave them. So if it has a 0 for the first piece of data, that means you point to if it has a 1, that means you point to the first vertex that the file specified. So, for example, let's look at this model. You can see in the first position it has 2/1/1 in the first vertex. And because it's pointing to a 2, you can see the second vertex that the file specified was 1, -1, 1. So that's the vertex position that it'll render for that face. The next set of numbers contains 3/2/1. And in this case, we're looking at the third vertex because it's 3 for the first number. So go to the top, count down 3. And that vertex is pointing to -1, -1, 1. Finally, the last set of numbers is 4/3/1, because the first number was 4. Count down 4 from the top of the vertices, and you see that's -1, -1, -1. And those are the vertex positions where we're going to be actually rendering the triangle to. So you go through the normal process that we've covered in the previous tutorials, transform each of those vertices to screen space, and then you simply rasterize a triangle on top of it. And when we actually load the model, what we're going to do is store a float for each individual number they specify. And when we're loading the face data, we're just going to assemble a new list of vertices, texture chords, and positions. And each one's going to be a unique combination of those three. So that's going to represent the new vertex data that you actually render. And then we're going to copy over the index list, and it'll work just fine. Alright, so what I'd like you to do is go into your include directory and actually create a new file called loader.h. And what we're going to do here is start with our include guards, if and def include loader h, define include loader h, and end if. So let's start off with some includes. We're going to need our defs.h, and now go ahead and add the vector include. And we also want string. So once we have all that added, what we're going to do is actually create a new class called index model. And essentially what that class is going to do is it's going to store all the data about the model. So create your class index model, create a couple of public variables, and let's name these, first create an int pointer for your indices. Make sure that's a pointer, not a normal integer. And now create a float pointer for the positions, a float pointer for the normals, and then finally a float pointer for the UVs. Now at the top, create an integer for the number of indices, call it index count. The last thing we want to do in this class is create a destructor, so index model destructor, and here we're just going to delete all these arrays because we're actually going to be allocating these on the heap. Delete indices, delete positions, delete normals, and delete UVs. Okay, so now go down here and create a bool load index model, a function. And this is going to take in a const std string reference for the file name. And the other parameter is an index model reference model. So this function is just going to be a definition here, but that's going to actually load the index model into, or load from the file into the index model. Before we go any further, go into the make file, add loader.h to there, and then to this side, model loader.cpp or model loader.o to the end after camera.o. Once you have that set up, we're going to need to create our new model loader file. So make model loader.cpp here, and then add the include guards as usual, or not the include guards, but include loader.h. That's what we want to do. So once we got that included, we're going to have to add fstream because we're loading a file. And then we also need an unordered map. Well, first let's get iostream, and then finally unordered map, because this is actually how we're going to be storing the vertices to make sure that they don't overlap. So go back into main and include loader.h. Now down here, we're just going to set up a simple function where we create an index model, and we call the load index model function, and if it fails, then we're going to return, well, we're going to say that it failed. And if it succeeded, we say that it did not, or that it succeeded. So if it succeeds here, stdc out loaded model successfully. And then otherwise, failed to load model. Alright, go back into model loader.h, and here we're going to do a simple definition is float character, and this is going to take in I, it's just going to be the character, and we're just going to do a couple tests to make sure that it's within there. So if it's greater than 0, if it's less than 9, or less than or equal to 9 and greater than or equal to 0, or if it's equal to a period or a minus sign, because those are all the characters that you can use inside of a float. Now if it's any of those, then that's going to return true. What we need to do here is create a function to actually split a string. This is something that is just going to be a helper function, we'll use it later, but just create std vector, std string split, const std string reference as an argument s, and then char ch. Now the code for this is really simple. Create a vector std string read, and then at the bottom just return that. And then we also need a temporary string, so std string L we'll call it. It's just a temporary variable. Now for int I equals 0, I is less than the size I++, iterate through the string. If the character is equal to the string character, then push back into the array the string, the full buffer, and then reset the buffer to null. And then otherwise we just append onto the temporary string the current value in the character. So that will essentially, well, at the bottom you need, if the size is greater than 0, then append it to the array. And that will split the string at the character. Make sure that you're testing if l.size is greater than 0. So now we just create a new function. We're just implementing the definition. You remember, you take the const string reference file path and the index model reference model. And here we're just going to return true for now, and we'll implement that in a second. Alright, so in load index model, start by creating a file object. So std ifstream file, and then put in the file path as an argument. Now we're going to have a string for the current line that we're loading, because we're going to load the file line by line. But first, let's create a vector of positions, normals, and UVs, temporary variables storing the current loaded state. Now we're going to load every line in the file. So do get line, add in the file as the input stream, and line as the output. And then if line.size is greater than or equal to 2, and I'll explain this in a second. And then if the line sub 0 is equal to v, and it equals space, then in this case we're loading a vertex. Essentially the way this loader is going to work is we're going to load the file line by line. If it starts with a v and a space, then it means it's going to load vertex data, if you remember from the explanation of the Obj file. If it starts with a vt, then of course we're going to load texture chord data. And then if it starts with a vn, we'll load the vertex normal data. And we're going to implement this by simply having a function that will load the correct number of floats from a line of text into the correct buffers. Now we're going to do else if line sub 0 is equal to v and line sub 1 is equal to t. And that's for texture coordinates. Our next else if statement is going to be for if the line sub 0 is equal to v and line sub 1 is equal to n. And what that's going to allow us to do is load normals. Alright, so now that that's all implemented, what we're going to do is actually implement the function for loading the floats. So go right above the index model method, load index model, bool load floats, and then this is going to take in a line, the line that we're editing, or the line that we just loaded, a vector of floats as the list, and a uint32t for the count. So that's going to be the number of floats to load. We're going to have an index to the string, which is going to start at 2 because we loaded v and t, or v in space. And then for each count, for each element, we're going to load a float. And we're going to keep track of that index through the line in order to load one float at a time. So then bool load float, we're going to take in the string of the line, string reference, and an integer for the current index of the line. And we're just going to be updating that as we load. Make sure to include a reference to a float as the return, because we're doing a boolean whether it succeeded or failed. Alright, so while it's a float char, while it's not a float char, we're going to increment the index because we want to get rid of all that space before, and then we want to make sure that we're not going out of the bounds of the string. And for each time of that, we increment index. And then if at the end of that we're not pointing to a float char, then obviously something went wrong. We reached the end of the line or something happened. But either way, we return false because there's an error. So now let's create a new size t for new index, set it equals 0. And then the float is equal to std s2f. And we're taking in the line.substring of the index. And then we are going to give it the address of new index. So that's going to be set to this, and because new index is set to the position of the substring, we have to increment index by new index. Now return index not equal to new index, because if it was the same, then it didn't load any data, so false. So now back into load floats. If we were able to load a float, because we need to make sure that we load as many floats as we expect. If we're not able to load a float, return false, and if we are, just continue through, and then push the element into the list. And then if it gets through all that, we would just return true at the end. So return true. Alright, the next step in our process of loading the file will be to go into, well, first let's take a look at the Obj file to load. I'm going to open up the cube, and this is just the data we're going to load. We're going to change it from B to cube in main.cpp, and let's give it a test. Okay, so you see it aborted the run because we deleted pointers that we never allocated in index model. So we might want to initialize those to null in the future. For now, I'm just going to comment out those lines. And now if we run it, it'll say model load successfully. Alright, so if we go back into model loader, all we have to do is in here. If we're able to load all the floats we expect, continue, otherwise return false. So if not load floats, return false at the end, but we need to give it the file, the line, and then the list, which is positions in this case. And the count is 3, because there's 3 positions, 3D space. So now load floats line, and this is the textures, remember? So we're only loading 2 floats for the texture coordinates, UVs, and give it 2. Make sure that that last coordinate is 2, or that last parameter is 2. And then when we load the normals, just go ahead and give it the normals array followed by 3. And that's all we have to do for this. Make sure to return false at the end. Okay, so here I'll go ahead and create a new structure for the vertices. And each vertex contains a position, a normal, and a UV. Now these are indices indices in the array, which we're going to initialize to -1 if they don't exist. Now remember, those are indices in the array, not actual values. So I'll just create these constructors. We're going to have a copy constructor too, because we're storing it in a hash map. So just make sure to set up the initialization list properly. Now also we want an operator equals. This will be for copying, so just take in the const vector reference, vertex reference, v, and then set all those variables accordingly. And then return a dereferentation of this. Next, we do need this one, operator equals for the comparator. Take in a const vertex reference v, and then just return whether or not each parameter is equal. So pose is equal to v.pose, norm is equal to v.norm, and uv is equal to v.uv. And if it gets through all that, it returns true. So now we need a hashing function. So create class vertex hash. We're going to need operator, const vertex. Make sure to have the operator equals const. And let's just rewrite this. We need to return a size t, operator parentheses. Taking a const vertex reference v, and the hashing function is going to return std hash of v.position, XOR hash of v.norm, and then .norm, and then XOR hash of v.uv. And make sure that each of those is an integer, because otherwise it won't compile. So just change all that to a template type int. Alright, so now that the hashing function is set up, we can move on to the actual storing of the data, the vertices. Let's start off with a list of indices as a std vector. So int indices, and then we need our unordered set, or unordered map. that has a vertex pointing to an int, which is the index, which also uses the vertex hash function. Name it vertices. Now that we've loaded all the data at this point, now we need to check to see if lines of 0 is equal to f. In this case, we're loading a face. So if, well, we can implement that in a second. First, we need to create a function load face. So if not load face, return false. So bool load face, take in a string for the line, and we need all the data of normals, positions, and UVs, and indices, and vertices. So just go ahead and load everything in as a reference to make it faster to actually run. A float of positions, int of indices, a float for normals, a vector of floats reference for UVs, and finally an unordered map with a vertex pointing to an int. Remember that int is the index of the vertex, with the vertex hash for vertices, and make sure that's a reference. We're good to go. So now on the implementation here, well, first let's put this onto a new line to make it a bit easier to read. But in the implementation of this function, it's not too difficult. It really isn't. All we need to do is create vertices, vertex 1, vertex 2, and vertex 3. And we're going to load data from the lines, check to see if they're already in the list. If they are, or if they are not, we're going to add them to the list and set their values accordingly. So this is where we're going to use the split function. Remember the way the file is formatted, it has spaces between each number set. So if we split up the spaces, we get a vector for each vertex of the face. And then if that's less than 4, obviously it's not the right file format because it's f followed by 3 sets of numbers. Now we need a vector for each vertex of strings. So we're going to split face sub 1 at the slash, face sub 2 at the slash, and face sub 3 at the slash for each of the different vertex datas. And now we just kind of compile the data into it. Now there are 3 different ways the data can be formatted here. You don't need 3 numbers necessarily, and that's where the complexity of the load face function comes from. If there's one element, that's this case, well, first of all, make sure that every element has the same size, because otherwise there was an error. So make sure that each of those has the same number of elements. Now for vertex 1, well, if it's a size of, excuse me there, if it's a size of 1, we need to load only positions. If it's a size of 2, we load the positions and UVs. And if it's a size of 3, then there are 2 cases. But first let's implement size of 1. We load the vertex position, S2I, V1, V0, and we subtract 1 because remember they're indexed by 1, not 0. Now, the pose, well, the second vertex's position is an integer conversion of the same thing but with V2. And once again, pose 3 uses the same thing but with V3 sub 0 minus 1. And that's all we have to do to load the position data. Remember, we're storing indices, not actual position values. Now, with a size of 2, it means that they only supplied 2 numbers, so it has to be the position and followed by the UVs. So we'll set the UVs here, and then the UVs would be stored in the first index of the arrays, so switch all those to 1. And remember, always subtract 1, very important. Now, there are 2 cases with a size of 3. Either the middle element is left out or the middle element is not left out. So if you check v1.size and if it's equal to 0, then the middle element was left out, so you don't load the UVs. But instead you just load the positions and the normals. So if we implement that here, we're loading 0, subtract 1. The same exact thing as before, vertex 2, vertex 3, and give it those parameters as normal. And remember, we're loading positions on the second one too. And then for this one, we're loading the normals. So just switch that all to norm, and then change the index to 1 at the end. So now you use v1 sub 1, v2 sub 1, and v3 sub 1. Or sorry, sub 2. I reiterated that incorrectly a number of times, so make sure that that's 2, not 1. Again, you load the normals, and then you also load the UVs. So we've loaded all the data for all three of those points. Now, the final step, well, obviously we have some incorrect tabbing here because of the fact that I put it on a new line, so let's just adjust that. And now we can finally add the indices. So if the vertex exists, so if vertices.find, if the vertex is already in the map, then there's no reason to add it. And we can just continue, but if it doesn't, then vertices sub vertex is equal to vertices.size, because that's the next vertex to add. So copy that 3 times, 1 for each vertex, vertex sub 2, vertex sub 2, vertex sub 3, vertex sub 3. So now that we've updated the list properly, indices.pushback, and then search the unordered set for each vertex, vertices sub vertex 1, and then do that for each of the indices. So that's going to search the hash map and find the exact element where that vertex is stored. And it will return as an integer, so that's the index in the array in which it's stored. And now just return true, and that is it for this function. So now if we just implement the f here, load face, give it the line, the indices, the position, the normals, the UVs, and then the set of vertices. That's all we have to do. Everything's set up. So now let's just give it a test. Print out the size, it should say 23. Oh, there's an error here. We have to definitely make the operator parentheses public in vertex hash, so make sure you go ahead and fix that. Next step, now that this should work, if we give it a run, it'll definitely work. You can see it prints out 24, which is correct for a cube. So now we're going to need to initialize the arrays in the index model. Create a new list of indices, and then we're going to need to give it a new array. So remember, each index points to 3 floats for the position. So we're going to need to multiply the vertices.size times 3, because there's 3 positions for every vertex. Same with the normals, and then for the UVs, there's 2. So equals new float, vertices.size times 2. Now, the next step here is to loop through every vertex and then write it to the correct indices in the arrays. So let's create an std iterator, well, an unordered map iterator, and we'll call it I, set it equal to vertices.begin, not equal to vertices.end, and I++. So the first element, I.first, stores the vertex, and I.second stores the index. So if we take position sub I.second, multiply it by 3, and then give it an offset of 0, we can set that equal to the positions array sub I.first.pose, remember that's the index in the array, times 3 plus 0. And that's all we have to do to load the first element of the array, and do that 3 times for every separate element. So plus 1, plus 2, and give that plus 2 and plus 1. And then we've loaded the positions array. So you can do the same thing with the normals. Remember, I.second is pointing to the index of the indice, and then the normals, the value at that vertex is pointing to the index of the array. So if you change it to first.norm and times 3 plus 1, everything is going to work out perfectly mathematically. Same thing with the UVs. Go ahead and throw that in, but we're going to rewrite it because we need to do times 2 instead, because there's 2 UVs for every 1 index, plus 0. is equal to UVs sub I dot first dot UV times 3 plus 0, or times 2 plus 0, my bad there. And now copy that once, and then just give it the separate offset of 1, and then we're loading each individual element of the UVs into the set. And that's all we have to do. So now all we have to do is copy the index array over, and while I'm doing this, I'm going to test whether this worked or not. So first set the model index count, and then loop through each index. And then we're going to print out, well, we're going to set model.indices sub I equal to indices sub I. Then we close the file. Make sure you do that. And I did some testing here. We need, in the face detection class, or is load face, you need to make sure that all of those say equals, not equals, because not equals will not work. So once you do that, it'll load properly. Make sure you go into the load face section and change all those hash map sets to equals instead of not equals. So back into the main file, load index model, return -1. And then if it failed to load the model, just print that out. Now, instead of returning 0, we can just continue loading. And before we do anything, we can go into the loader.h and bring back the deletes, because I don't really want those to not free the memory. And take the index model definition at the top of the function, put that in the global scope. Now we can get rid of each vector 4, because we're not going to be rendering with those vector 4s anymore. We're going to be rendering with the loaded models. So what we have to do is, well, once we load the model, we're going to basically just loop through every index, and we're going to skip 3, so vector 4 v1, and we don't need to do an operator equals here, we can just do a parentheses constructor initialization. But for every index in the model, so for int I equals 0, I is less than model.indexCount, or we need to do model.indexCount, not models.indices.size. Then we just take each of these vertices, and then we create the triangle from the loaded thing. Now here, rasterizer.clearFrame is right before rasterize triangle. We can put that at the beginning of the function, because otherwise it'll clear the screen after rendering a triangle. It's not going to be good. So put that at the top. Now here, we can just initialize v1, and I've already gone ahead and taken the liberty to write the code for this. It's going to be model.positions, and you take the index, multiply it by 3, and then give it the offset. So multiply it by 3 or 2 depending on whether it's a UV, but for positions it's 3. So you take the index sub I, multiply it by 3, and then give it an offset of 0. Make sure that last vector 4 value is 1. Give it an offset of 0 for the first element, and then the next element needs to be an offset of 1, and then the last one is an offset of 2. And then this side is an offset of 1 and 2 again. And same thing for the last element in the set. So 0. Now there's one more modification. We got to change the offsets of the positions, because each of those positions needs to be offset depending on its area. So it's 1 for the middle and 2 for the outside, because we're taking the index and then going over 2, and then we're going over 1, and then the first one can stay the same at 0. So now with each of those vertices loaded, we can go ahead and give this a run. Make sure it builds, and it does. So go ahead and make run here, and you can see the cube is actually already rendering. So I'm gonna move the cube a bit further away, so -3, and actually made a mistake here. We need to normalize, two mistakes. We need to normalize the rotation vector. And lastly, we actually need to add 3 and not 1, otherwise we're going to run into some issues. So do I plus equals 3, not I plus equals 1. And now if we make run, you can see the cube is spinning in the middle of the screen. It looks beautiful. Let's go back to the main.cpp one more time and change the model to the B. So let's change it to b.obj, make the position a lot closer because it's a much smaller model, and give it a different axis of rotation, 0.2 and 0.4 on those. And then if we make run, we should be able to see a B spinning, and there it is. It was able to load the model from the beginning of the tutorial, and every triangle is rasterized flawlessly. That's perfect. So all I can say is we're at a major milestone here. We're loading models from files. Upcoming, we're going to have lighting, texture effects, clipping planes, null, or back face calling. It's going to be awesome. But now that we got the model set up, we are ready to get rolling. So you can expect my next tutorial probably within a week. I'm hoping I can get it out by then. I know I haven't had the most consistent upload schedule, but I'm hoping I can fix that in the future. So I hope you learned, I hope you enjoyed, and I will see you all next time. Before I go, if you've made it this far, I want to give a quick shout out to another content creator, Casual Coder. He's recently hit 1,000 subs and he makes some killer Ncurses content. If you're interested in learning how to take full advantage of Ncurses in the terminal, go ahead and check out his channel and subscribe. I'll be sure to leave a link in the description.